You can go from 0 to 1 with an x. What would be the two symbols?
Greater than 0, less than
Equal to, but it does not hit 1. So it would be greater than or equal to.
Careful. The x is bigger than the 0, right? So it's less than or equal to. 0 is less than or equal to x, which is less than 1. If you want to use interval notation, what would you have?
bracket on the left, parentheses on the right.
Bracket on the left, parentheses on the right. Okay. Okay, let's actually do something with that because that's a weird equation. You will see stuff where you need to evaluate a function. That is one of those step functions. Okay? So if I have negative 3 halves, 1, and negative 5 halves, the idea is that I'm plugging those into this function. So what ends up inside of these, try not to make an actual bracket. What ends up inside of this? In other words, just what's negative 3 halves plus 2?
Negative 1/2.
Negative 3 halves plus 2?
Negative half.
1 half.
Just a half.
Negative 1.5 plus 2 is? Okay. Now, greatest integer function. The idea is it's the greatest integer you've gotten to as you went from left to right before you reach that number. So what would it round to? 0. Okay, ones like this make it very easy. Because what would be the answer? 3. Because you don't have to round at all. It already is an integer. What about negative 5 halves plus 2? What ends up inside the symbols? Negative 0.5, or negative half.
Round down the negative 1.
So it'll round down the negative 1. This thing's also called the rounding down function because it always rounds down. If you think about it in terms of a number line, it's always whatever you just hit as you went left to right before you got there. Okay. It's something that honestly comes up very rarely, but does show up in a few cases. We won't do much with it. It's a lot more business applications, like quantity things where you can't have half of something. But then they pay a mathematician to do it for them, so they don't have to look at it. Next up, piecewise functions we already talked about. Those are the ones where you have multiple things for each function. Let's actually do something with that, though. If I want to have this graph and I want to sketch the graph. Not as bad as it looks because in reality, this part's just telling you the limitations on it. So the real graph is this. Well, what type of graphs are those? Lines. So you're just graphing two different lines. But you're only graphing part of each one. So if I graph the top and the bottom line, honestly, I'm going to do the bottom line first because where's the y-axis at? Which one hits the y-axis? The bottom one, because it's when x is bigger than negative 4. It's going to include x equals 0, right? So that one's going to hit the y-axis. So I can graph that pretty easy because the y-intercept is accurate. What's the y-intercept? On the bottom equation, what's the y-intercept? 5. So I'm just going to go up 5. So it hits there. And then what's the slope? 1. Now I'm going to go, I could go over and to the right, but honestly, who cares because everything interesting is going on to the left of this. How far, or where do I want to stop going left?
It would be a horizontal, or you would start before it's not equal.
Well, careful. It's the x value that matters there, right? So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and then finally here when I get to negative 4 on the x, that's going to be the open circle. Okay. So you have an open circle there, and then just a line going uphill, pretending I hit all those points. Okay? Now, for the other one, what would the y-intercept be if it hit? Negative 6. So it would start here, but because it doesn't reach that, what's the slope? Negative 1/2. So I'm going to go down 1, right 2, or up 1, left 2. Then I'm going to go up 1, left 2 again. And this is nowhere near to scale. This thing's finally going to start here, because then I'm finally 4 to the left. Filled in circle or open circle? Filled in. Okay. And then keep going with that slope. Up 1, left 2. Up 1, left 2. Up 1, left 2. And go from there along that line. There's your graph. See that? You have your open circle there, your closed circle below it. Now, if you're graphing on the calculator, the problem is there is a way to force it to do this, but it's honestly not worth the trouble. You have to do commas and different things and set the x values. And honestly, if you want to graph it and check if you're right, just graph both lines and just mentally realize, okay, I'm only doing this much of this line. I'm only doing this much of this line. Questions on that? Okay, last thing. Absolute value function. What does this one look like? A V shape. What would the domain be? All real numbers. Range? All real numbers y greater than or equal to 0 would work. All non-negative reals would also work. Intercepts?
Origin.
The origin. Symmetries?
Reflection.
Reflection over the y-axis. When is it increasing? Over what interval? From 0 to infinity. Or negative infinity to 0 for decreasing. Or x is greater than 0, x is less than 0. Questions on any of it? Okay. That's it for today. The rest of the time is yours to work.